In 1977, twin spacecraft named Voyager 1 and Voyager 2, launched by NASA, inspired the world with their pioneering visits to Jupiter, Saturn, Uranus, and Neptune. For 45 years, both have continued to explore interstellar space, the region outside the protective heliosphere created by our Sun. Researchers are now using data received from Voyager to unravel the mysteries of the solar system and beyond. NASA's twin Voyager probes were in many ways time capsules of their era. Each carries an 8-track tape recorder to record data. They transmit data about 38,000 times slower than a 5G internet connection and have about 3 million times less memory than modern cell phones. Despite this, the Voyagers remain at the forefront of space exploration. So what are they doing now? What will they encounter? Let's find out together. If the sky conditions hadn't been so perfect, two of the most remarkable spacecraft ever launched would never have left Earth. In this case, we can say that the conditions were actually the 4 largest planets in the solar system. As a result of this coincidence, the spacecraft gained a speed boost thanks to the gravitational assistance of each giant planet they passed. Gravitational assistance meant that the planets would slingshot objects leaving their orbit like a slingshot. Therefore, according to the calculations, repeated gravitational assists reduced the flight time between Earth and Neptune from 30 years to 12. But there was a problem. The alignment of the planets to create suitable conditions only occurred once every 176 years. To reach the planets while they were aligned, the spacecraft needed to be launched in the mid-1970s. As a result, NASA built 2 spacecraft to take advantage of this opportunity that occurs almost once every 2 centuries. The completely equivalent Voyager 1 and Voyager 2 were launched 15 days apart in the summer of 1977. The Voyager duo traveled farther and stayed in space longer than any other spacecraft in history. They left the Sun's domain and entered interstellar space. As the first man-made objects to do so, they hold an achievement that will last at least a few more decades. Did you know that the Voyager missions were originally planned to last only 4 years? 40 years ago, the Voyagers provided the first close-up images of the moons of Jupiter and Saturn. Astronomers thought these moons would be as calm and uneventful as our own moon. Thanks to the images obtained, the existence of active volcanoes and cracked ice fields on celestial bodies was revealed. In 1986, Voyager 2 became the first spacecraft to pass Uranus, and 3 years later, it passed Neptune. Voyager 2 is the only spacecraft to have made such journeys so far. Today, at a distance of more than 19 billion kilometers from Earth, they surprise theorists with a series of unexpected data about this undiscovered region as pioneering interstellar probes. The extraordinary adventures of the Voyagers are now coming to an end. Over the past 3 years, NASA has decided to use the spacecraft's remaining energy reserves to extend their unique journeys until 2030 by shutting down heaters and other non-essential components. For most scientists who have been on the mission since its inception, this is like the end of an era. They are faced with the end of a project that has more than met all their expectations. Voyager 1 reached Jupiter in March 1979, 546 days after launch. Voyager 2, following a different trajectory, arrived at the planet in July of the same year. Both spacecraft were suitably designed to carry special cameras that used red, green, and blue filters to produce full-color images. Even when they accelerate in space, they hardly rotate. Their rotational movements are 15 times slower than the hour hand of a clock, which minimizes the risk of blurry images. The spacecraft began transmitting the first images of Jupiter while still about 3 or 4 months away from the planet. This was a big day for scientists at the Jet Propulsion Laboratory. The color images of Jupiter's moon Io were beyond expectations. Before the Voyagers proved otherwise, there was an assumption that all the moons in the solar system would be roughly the same. No one expected the moonscapes around Jupiter and Saturn to be so diverse. The first clue to this event came when the Voyagers were still about 1.5 million kilometers from Jupiter. The low-energy charged particle detector system picked up some unusual signals. The Voyagers' cameras quickly solved the mystery. Io had active volcanoes. This small celestial body, slightly larger than Earth's moon, is now known to be the most volcanically active body in the solar system. It was understood that Io's colors and the anomalous ions hitting the detector came from elements ejected from the moon's volcanoes. Eruptions from Io's largest volcano, Pele, reach 30 times the height of Mount Everest. The debris created by Pele covers an area the size of France. The Voyagers took a total of more than 33,000 photographs of Jupiter and its moons. Each image seemed to mark a new discovery. For example, Jupiter had rings. Also, Europa, one of Jupiter's 53 known moons, was covered in an icy, fissured crust, now estimated to be more than 95 kilometers thick. When it was time to leave, the spacecraft took gravitational assistance from Jupiter and moved away at a speed of 60,300 kilometers per hour. Without this gravitational assist, they would not be able to overcome the sun's gravitational pull and reach interstellar space. As for Saturn, the Voyagers parted ways. Voyager 1 blasted through Saturn's rings and headed north, flying past Titan, a moon shrouded in orange smoke. Voyager 2 continued its visits to Uranus and Neptune alone. In 1986, Voyager 2 found 10 new moons around Uranus, adding the planet to the growing list of ringed worlds. 3 years later, it passed about 4,800 kilometers above Neptune's deep blue methane atmosphere, showing that the planet has the highest wind speed in the solar system. Neptune's winds were blowing at speeds of up to 1,600 kilometers per hour. It was also seen that Triton, Neptune's largest moon, is one of the coldest places in the solar system, with a surface temperature of -235 degrees. Ice volcanoes on it were spewing nitrogen gas and dust particles over an area of 8 kilometers. When the grand tour was officially completed, NASA planned to shut down the cameras on both probes. Carl Sagan, speaking with NASA officials, gave Voyager 1 one last chance to capture a few images. So, on Valentine's Day in 1990, the probe pointed its cameras toward the inner solar system and made its final 60 shots. From a distance of 6 billion kilometers, the spacecraft took a picture of Earth, dubbed the pale blue dot by Sagan. The photograph remains the most distant picture of our planet ever taken. The Earth, covered with the faint sunlight reflecting off the camera's optics, is barely visible, so much so that it doesn't even occupy a full pixel. Without Carl Sagan, Voyager 2's images of Neptune and its moons would have been the last images taken by any of the spacecraft. Although the mission was extended in the hope that the Voyagers would reach interstellar space, there would be no imaging after Neptune. All we could see would be infinite emptiness and unattainably distant stars, and the mission would not be renamed Voyager Interstellar Mission. Both Voyagers are now so far from Earth that it takes about 22 hours for a one-way radio signal traveling at the speed of light to reach Voyager 1 and 18 hours to reach Voyager 2. Every day they move 3 to 4 light seconds further away. Their only connection to Earth is the NASA Deep Space Network, a tracking trio located around the world that provides uninterrupted communication with them. As the Voyagers move away from us in space and time, their signals become increasingly faint. Earth is a noisy place. Radios, televisions, cell phones, and everything else makes noise, so it's getting harder and harder to hear these tiny whispers coming from the spacecraft. These whispers exceeded researchers' expectations of what the Voyagers would find as they entered the interstellar phase of the mission. The boundary of interstellar space should not be conflated with that of the solar system. The solar system contains the Oort cloud, a spherical collection of comet-like objects bound by the sun's gravity. The Voyagers won't reach the vicinity of the cloud for at least another 300 years, but interstellar space begins much closer, where the solar winds end. Like all stars, the sun emits a constant stream of charged particles and a magnetic field, which is the solar wind. The wind, moving at supersonic speeds, creates what astronomers call the heliosphere. As the solar wind ripples through space, it pulls the sun's magnetic field with it. As a result, pressure from interstellar matter controls the expansion of the heliosphere, creating a boundary with interstellar space. Before the Voyagers began their journey, distance estimates to the boundary between interstellar space and the solar system, known as the heliopause, varied wildly. According to physicist Donald Gurnett, initial estimates showed the heliopause to be as close as Jupiter. Gurnett's calculations in 1993 put the distance between 116 and 177 astronomical units. These estimates were not well accepted among his colleagues. In 1993, Voyager 1's odometer showed 50 astronomical units. If the heliopause was 120 units away, that meant there were 70 more astronomical units to go. If Gurnett was right, the Voyagers, traveling at about 3.5 units per year, wouldn't leave the heliosphere for at least another 20 years. Surprisingly, Gurnett's predictions turned out to be correct. It took almost 20 years for one of the Voyagers to finally reach the heliopause. During this time, the mission barely survived threats to its funding. The Voyager team was reduced from hundreds of scientists and engineers to a team of a few dozen. Although Voyager 1 did indeed find the expected jump in plasma density, there was no sign of a change in the direction of the ambient magnetic field. Wouldn't this transition be noticeable if the vehicle had passed from a region permeated by the sun's magnetic field to a region where there was a magnetic field derived from other stars? This was shocking. Voyager 2 reached the interstellar boundary in November 2018, but it also failed to detect a magnetic field shift. The spacecraft also added another puzzle. It encountered the heliopause at a distance of 120 astronomical units from Earth, the same distance its twin arrived 6 years earlier. This was inconsistent with any theoretical model, suggesting that the heliosphere should expand and contract in tandem with the Sun's 11-year cycle. Voyager 2 arrived at its destination when the solar winds were at their strongest. But if the models were correct, the winds should have pushed the heliopause further than 120 units. With the field data the Voyagers have given theorists, models of the interaction between the heliosphere and the interstellar medium have become more complex. Looking at the big picture, our Sun emerged from a hot, ionized region and entered a choppy, partially ionized region in the galaxy. The hot region, probably formed by the explosion of one and several stars, heated space, separating electrons from their atoms. The boundary around this region can be thought of as all the waves on a kind of seashore swirling into a vortex. Since we are in such a turbulent region, the magnetic fields are constantly moving. Although the region is not like the smooth magnetic fields theorists usually see, the amount of turbulence seen can vary depending on the type of observation. The Voyager's data revealed many fluctuations around the heliopause caused by the heliosphere. It is thought that at some point the spacecraft will leave these fluctuations behind and finally encounter the interstellar magnetic field in all its tranquility. It won't be easy to say goodbye to these groundbreaking, pioneering vehicles. It must be especially difficult for researchers to see the end of a mission they have been a part of for decades. On the other hand, they have done truly tremendous things during this time. They might not have made it to the heliopause, but they did. Now Voyager 2 has 5 and Voyager 1 has 4 working devices left. All are powered by a device that converts heat from the radioactive decay of plutonium into electricity. But with power output decreasing by about 4 watts per year, NASA has had to prioritize. 2 years ago, engineers turned off the heater for the cosmic ray detector, which played a crucial role in identifying the heliopause transition. Everyone thought the detector would stop working. Its temperature dropped by 60 to 70 degrees. This was well outside the tested operating limits, and incredibly, the device continued to operate. Even after the Voyagers are completely muted, their journey will continue. In 16,700 years, Voyager 1 will pass by our nearest neighbor star, Proxima Centauri, followed by Voyager 2 in 3,600 years. They will continue to roam the galaxy for millions of years. Even eons after our sun dies and our pale blue dot is gone, they will still be there, almost intact. At some point in their journey, they may manage to deliver a final message. If anyone picks up the incoming message, it won't be humans. The Voyager's messages are carried not by radios, but by a much older technology, records. Of course, these are not like the plastic records that come to mind. The copper discs were coated with gold and finally sealed with an aluminum cover. The artifacts, called the Voyager Golden Records, consist of images and sounds intended to give extraterrestrial life forms an idea about our planet. It includes pictures of children, dolphins, dancers, and sunsets, as well as the sounds of crickets, falling rain, and a mother kissing her child. The message of the plates doesn't stop there. They carry 90 minutes of music, including Bach's Brandenburg Concerto and Chuck Berry's Johnny B. Good. Jimmy Carter, who was the US president when the Voyagers were launched, also left a message on the records. In his message, "We are sending this message to the universe. We hope to one day join the community of galactic civilizations by solving the problems we face. This record represents our hope, determination, and goodwill in the vast, awesome universe." Use the phrases. Do you think these messages sent from Earth will one day reach a civilization? If it does, Will we be able to learn about it? Or will we have perished along with the Earth by then? We leave the floor to you. Thanks for watching. Don't forget to subscribe for interesting and new information. See you in the next videos.